Firecast, a podcast from MDM Publishing, brought to you in association with International Fire Protection Magazine, the global voice for passive and active fire protection.
Welcome to this latest Firecast, where we discuss some of the big issues with the experts in the fire industry. Hello, I'm Paul Hutton, and today it's my pleasure to talk to Mark Kendall, General Manager at Fike Safety Technology, because I want to know more about energy storage systems and how to keep them safe. Now, battery fires within energy storage systems aren't as rare as you might think, but the reason they're often underpublicized, and fortunately there haven't been more tragedies, such as the 4 critically injured firefighters in Arizona in 2019, is because on the whole, ESSs are often installed away from residential or commercial areas. So I've asked Mark onto the podcast because I want to know why it's critical for local authorities having jurisdiction, firefighters, city planners and decision makers to understand the hazards of ESSs and be educated on the best methods to protect them from the phenomenon known as thermal runaway. So Mark, welcome to the Firecast. Thanks for joining us.
Hello.
And let's begin by explaining the role of energy storage systems and why their usage continues to expand.
Well, this is really coming from the increased uptake in renewable energy generation. And one of the big problems with most renewable technologies is they're not consistent. So we look at wind, for instance, they only generate electricity when the wind blows. We look at solar, only generate electricity during the day. But we need to be able to use that energy consistently. So the energy storage systems act as a buffer, if you like, between the renewable energy generation and our demand on the grid. So they're big battery units that provide that buffer to provide the consistency in our demand use.
And I guess at the moment, they're, as I said in the introduction, stored away from residential areas. But I guess as more and more are needed, they're going to start encroaching on where people live?
Yeah, absolutely. And we already see that in domestic scale solar, for instance. So not only do people have solar energy on their roof, there are small scale energy storage systems connected to those. So small battery packs within the property somewhere. This is a generally a bigger version of that. And like I say, they are kept away from built up areas, mainly because of the risks involved with the battery storage. As technology moves on, we do see these moving, or the requirement for these to move closer to built up areas or areas where the actual demand is required.
So explain to me what thermal runaway is all about. How are the cells within an ESS generating the heat that causes the extreme fire risk?
So there's a few terms that are kind of all rolled into the definition of thermal runaway, but they are actually very different kind of pieces of the same problem. So you have 4 major components to a battery. You have an anode and a cathode, which are the 2 bits you connect to normally. You then have an electrolyte running through that battery and a separator material that separates the 2 sides from each other. In the event of certain conditions like overcharging, the battery getting too hot, puncturing the battery, all of these kind of abuse factors, what happens is you get an internal short with that battery. So the separator material breaks down and the anode and the cathode short together within the battery. That is a chemical reaction that generates a huge amount of heat. It's an exothermic reaction. So yeah, it produces heat. It also produces large amounts of hydrogen fluoride, and oxygen, depending on the battery chemistry. So you've got heat and then you've got combustible gases. So once that cell goes into thermal runaway, this process has started, and in a single cell, that process can't be stopped. It's going to carry on going until the cell's consumed. But you then have kind of 2 other effects that follow on from that. One of them is that the heat generated in that first cell starts to warm up the second cell. So thermal runaway is in a single cell. What you can then see is cascading thermal runaway, where the first cell heats up the other cells and sends them into thermal runaway as well. So this process cascades on through until all of the cells, all of the fuel within that battery has been consumed. When a cell goes into thermal runaway, like I said, it starts to produce gases. Now, those gases are also very, very flammable. So that's where we start seeing these lithium ion fires. And a lithium ion fire is the gases produced by a cell that's in thermal runaway catching fire. And you see the visible effects of the flame there. So that's the different stages. You've got thermal runaway in a single cell. That single cell will produce off gases, which can be flammable and catch fire. So that's the off gassing and a lithium ion fire. And then we have cascading thermal runaway, which is the heat affecting the cells next to it and sending those into thermal runaway as well. So it's a very complex, multifaceted problem that we need to solve. And currently, we're kind of really only looking at the lithium ion fire part of this, not the whole situation holistically.
So what do we need to do to look at them holistically?
What we need to do is look at the initial cause, which is the thermal runaway in the first cell. And what we've got to stop is that cell from heating up the adjacent cells. Because if we can contain the problem to one cell, the amount of gas, the amount of flammable material that's being produced by that one cell is more limited. As soon as we start affecting the other cells, we're producing a lot more gas. We have a higher risk of fire, a volatile environment, all of these things. So we need to stop the transfer of heat from cell to cell is ultimately what we're trying to achieve.
And what are the current methods that are used to do that?
To stop the transfer of heat, there isn't really anything available up until now. What the traditional methods are really looking at is stopping the fire. So a cell will go into thermal runaway, it'll start off gassing, the off gases will catch fire and any plastics and anything else around that cell. And the traditional methods will put that fire down. Now, the problem that you then get, because you haven't stopped the thermal runaway event, those cells are still producing massive amounts of gas. So when the hold time of your agent is elapsed, or as happened in Arizona, the firefighters get there and open the door and you have an inrush of oxygen, those gases can then either catch fire again or in worst case explode, which was what happened in Arizona.
So what can be done about it, and what are we working on as an industry to actually overcome the problem?
So we went through a process of testing the agents that we have, everything that was available to us, and realized that this actually is a problem and we need to not just be tackling the effects of the problem, but stopping it at the source. So we've developed a fluid with a very, very high heat capacity that can be injected into the batteries when we pick up that there's a problem, that one of the cells has gone into thermal runaway. That fluid's job is to suck all of the heat out of that first cell and dissipate it throughout the liquid in such a way that it doesn't allow the temperatures of the adjacent cells to increase to a point where they enter thermal runaway. So ultimately, we're putting a liquid in there that is going to absorb all of that heat very, very quickly and get rid of it before it's got a chance to affect the other cells.
That's fascinating. So does it work?
Absolutely. We've been through, and part of this process is, it's one of the great things with working for Fike is we've got some awesome people that once we set our minds to solving a problem, we'll achieve that aim. One of the other good things is we have our own test facility. So very early on, we realized we needed to invest in that, and we put a lot of money and effort into developing our test capability. That allowed us to run a number of iterative tests to really dial this fluid in and make sure we had it as optimized as possible for this application. Once we'd been through that, we then went to the Canadian Standards Authority, and we got third-party testing done on the application to validate what we'd seen in our own testing and to make sure that actually came through in the third-party testing. That Set of test procedures went incredibly well, which is why we've decided to really commercialize and launch Fike Blue as a product off the back of that third-party testing.
This could be a real game changer then, couldn't it, Mark? I mean, what does it mean for energy storage, safety, and renewable energy?
Absolutely, it could be a game changer. And realistically, it allows the large grid scale energy storage solutions to be deployed more locally to where the demand's needed. When we look at applications where we're trying to replace standby diesel generators. So if you look at hospitals, as you need a backup diesel generator there. Ideally, we'd like to be using more battery related solutions. It allows us now to do that safely without any risk of, should the worst happen, it's not going to be a big event. It's going to be a controlled, managed event that doesn't put anybody at risk.
And in talking to firefighters and highways authorities, there is a genuine concern over electric vehicles and electric vehicle fires. Is this a potential solution in these sorts of batteries as they're moving around?
It's something we're looking at. As it stands at the moment, it would be a challenging application to fit the product to, mainly because we're using a fluid under stored pressure, which would be like carrying a quite a large fire extinguisher around in the battery. But the technology and the science behind it is possible to adapt that. And that's sort of the things we're looking at now is can this be adapted to solve problems in the EV market or for the firefighters addressing EV issues when they come up to those EV fires?
Fascinating. So, right, imagine I'm a battery manufacturer or I'm an owner of an ESS and I want to install Fike Blue on my system. What's the process I'd have to follow?
The first thing would just be to contact us and have a discovery meeting around. One of the key things with ESS is every battery is different. The chemical makeup of the battery, the physical construction of the battery, all of these things play a part in how that battery enters and develops thermal runaway conditions, and what you need to do in order to stop that. So we really take a consultative approach with the battery manufacturers or the ESS manufacturers, work with them, understand their batteries, understand the layouts of the ESS and how best we can either put the solution in there or what type of delivery method would then be best for that particular application. Once we've kind of got an outline concept, we'll then go into a testing phase. Everything that we do, we test to make sure that it's 100%. Ideally, if the client wants to then go to a UL 9540A test, which is kind of becoming one of the de facto tests for the ESS market, we can help them to achieve that third-party testing as well. So it's a complete end-to-end solution, and we help at every stage.
And you're talking about the fact that you're constantly testing at your own innovation center. Is that something that a potential customer could actually come and witness a test and see it for themselves?
Absolutely. We more than welcome it. And again, with third-party testing, if the customer wants to bring a third party that needs to see validation or proof of testing, then that is something that we would openly welcome. Like I say, performance-based testing is critical for this application, and the more of that that's done, the better our knowledge will be moving forwards.
So I said earlier, I used the phrase game changer, and that's often overused, but genuinely, it sounds like this could definitely be a game changer. What's next for Fike Blue and what's next for energy storage safety?
Well, that's the real question. We've got lots of ideas. There's some pretty crazy stuff going out there. But again, it's looking at those applications outside of ESS that are aligned where this could really help solve some challenges that occur. So anywhere where we're looking at lithium-ion batteries en masse or possibly mass storage is where we're looking for the product. We're playing around with changing the form from fluid to other types of medium for particular applications. But At the moment, it's really exciting because what can we use this for? I think we'll see it in a number of different applications, even outside of the lithium ion space.
Wow. Mark Kendall is General Manager at Fike Safety Technology, and he knows a lot about energy storage systems and their safety. And thanks to him sharing 15 minutes of his time, you know more about it too than you did 15 minutes ago. Thank you, Mark, for joining us today, and thank you for listening to this Firecast. I'm Paul Hutton, and I'll join you again soon.
Firecast is produced and presented by Paul Hutton and is an MDM Publishing podcast in association with International Fire Protection Magazine.